2F, exponents and radicals. Okay, so now we're going to start talking about exponential expressions. An exponential expression is basically a representation of repeated multiplication. And it's usually written in the form a to the n, where a is the base and n is the exponent. And what it represents is the base being taken however many times n is and multiplied together. So you'd have a times a times a times a times dot 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 times a n times. Okay, so that's a generic form, putting it with letters. Let's just throw some numbers in there so we can see what it's really doing. So we have 5 to the third, 5 being the base, 3 being the exponent or the power. And what that's saying is we're going to take 3 5s and multiply them together. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. So that right there is how an exponent works. Take this many of the base and multiply them together. Now I'm very careful about how I word that, because many times you'll hear people say, take 5 and multiply it together 3 times. And I don't quite agree with that wording, because you'll notice we'll only multiply twice. So this is how many 5s we're multiplying together. So we're taking 3 5s and multiplying together. If we have 2 to the 4, then we're taking 4 2s and multiplying together. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And that's how exponents work. Pretty straightforward. It's just repeated multiplication. Now sometimes when we're dealing with exponents, they're a little bigger than what we want to deal with by hand. If I say 7 to the 8th power, or 7 raised to the 8th, that means we've got to take 8 of these 7s. That's equal to 7 times 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 7. Well, that's a lot of multiplication. I can start out 7 times 7 is 49, times 7 is 343, times, forget it. At that point, okay, there's got to be an easier way. Well, this is where we take out a calculator and put the calculator to work. So I'm going to grab a calculator. Okay, so I just grabbed a calculator, and what I'm going to do is I've got 7 to the 8th, so I'm going to go into the calculator and I'm going to plug this in. Now, depending on the type of calculator you have, your exponent button here may be a little hat symbol. It may say y to the x. It may do something like x to the box. Okay? There's a variety of different ways that it could be done. On this particular calculator, it has the little hat button. It's hard to see here, but it's over on this right-hand side. So we got the little hat button. So if I want to do 7 to the 8th, I'm going to go 7 hat 8. That's what I'm going to plug into my calculator. So 7 hat 8, and I hit enter, and that's going to give me 5764801. Put a couple commas in there, and we find out that it's 5,764,801. So that works, and that's a lot easier than trying to do it by hand. So when we get into these larger exponents, use a calculator. Let it do the work. So instead of having to write all this out, I can just go 7 to the 8th is equal to, plug it in the calculator, 5,764,801. And I can get the result. Let's try another one. Well, let's go for 13 to the 19th. So 13 to the 19th. We can already see I would not want to have to write that one out. I don't want to write out 13 19 times and then multiply it all together. So we got 13 to the 19th. And my calculator tells me that's 1.46192029 E21. Now, if you remember when we talked about scientific notation, that scientific notation, it actually means that's 1.46, and I'm just going to round to 2 decimal places, times 10 to the 21. So that's essentially what it's telling us. And since that 21 is a positive power, that means this decimal point would get moved over 21 places to the right. Now, it's a good thing we covered scientific notation already, because your calculator just can't display such a large number. It's just not possible. So it has to put it into scientific notation. And we can see that we can pull it out of there. When you do get a result in scientific notation, I know you're tempted to write down the whole thing, 1.46192029 E21. First of all, that's not correct notation if you're writing it out for a teacher or anybody, because that's something your calculator does to tell you, but that's not really scientific notation. You have to put it times 10 to the 21. Secondly, this has been rounded to that decimal place. So this isn't the exact value. If you were to move this over 21 places and fill the rest in with zeros, that would not be an exact value. It would still be rounded to that place. So in most cases, you might as well just round it to 2 or 3 decimal places when you have it in scientific notation. So 1.46 times 10 to the 21. Well, let's do a couple other ones and change things a little bit. What if we have a base that's not a whole number? So 3.4 to the 9. 3.4 to the 9. Well, again, definitely would not want to have to do that by hand, because once you start dealing with multiplying decimals over and over again, it just gets horrible. So, and I can look at this and go, well, if I were to do that, I would end up with 9 decimal places involved and some relatively large number. So luckily, I can just go 3.4 raised to the 9th power, and I get approximately 60716.99277, or I can say that's approximately 60716.99. So 60,716 and 99 hundredths, approximately. So realize with this, you're just kind of running out of spaces. It already is giving us 10 digits, and that's about as high as my calculator likes to give me. So realize it may round on the end. But that's what's going to happen. We're just multiplying decimal numbers together. And of course, you multiply decimal numbers together, you're likely to get a decimal result. So having a decimal for the base, not much effect. What if we have a decimal for the exponent? Because that seems like that would throw things off a little bit. So let's try a couple. First, I'm going to do 9 to the 4.5. So 9 to the 4.5. Well, first of all, doing this by hand seems difficult, because sure, I can write out 9 times 9 times 9 times 9. But what do? Write out times not, give myself half of a 9? I can't do that, right? So that's not going to work well, doing it by hand in that way. So we plug it into the calculator, and you get 9 to the 4.5 And it actually turns out to be a whole number, mainly because that's the way I set it up to be. But we come out to 19,683. So 9 to the 4.5 comes out to be a whole number. But if we have a whole number raised to a decimal power, it's not always going to turn out to be a whole number. In fact, it's very likely that it won't. What if we try 12 to the 3.7? So I go 12 to the 3.7, and I get 9,839.445179. Okay, so as we see, it's going to cause these issues. Now, one of the main things I want to point out to you about dealing with exponents, okay, just keep in mind when you're dealing with exponents that you're multiplying this number together, the base, that many times. So it means you're going to take 4.5 nines, which is hard to say as a decimal form, right, for an exponent. But remember, it's multiplying that base number together again and again and again and again. It is not multiplying the base times the exponent. If I do 9 times 4.5, I get 40.5, which is definitely wrong. So keep that in mind. It is not just simple multiplication, this times that. That is wrong. You're multiplying that base together again and again and again. And that's a very common mistake that I see people make. A couple more things to be familiar with exponents. First of all, any number raised to the first power, so a to the 1, gives you that number back. So if I have 13 to the 1, that is 13. If I have 24 to the 1, 24. If I have 697 to the 1, 697. Because what are you doing? Well, you're taking this many of those and multiplying together. Well, that's one of those. You're taking 113 and there's nothing to multiply it by, so it's just 13. So any number raised to the first power is just going to give you that number back. Another thing is, any number raised to the 0th power is 1. As long as that number is not equal to 0. Okay, we'll get to that in just a moment. But you take any number and raise it to the 0th power, then you're going to get 1 as the result. So 5 to the 0 is 1. And when you get into statistics and you start getting into the counting principle, that's going to actually show you where this comes from. If your teacher teaches it the way that I do, that you're going to get to see why any number to the 0th power is equal to 1 when you get into permutations and combinations. But that's the way it is. Any number to the 0th power is equal to 1. 0 raised to any power is equal to 0 as long as that power is not 0. So that makes sense, because if you multiply any number by 0, you're going to get 0. So if you multiply 0 together numerous times, 0 times 0 times 0 times 0 times 0, you're going to get 0. That's all there is to it. So any number to any 0 to then any number is equal to 0. So if I have 0 to the 7th, that's the same as going 0 times 0 times 0 times 0 times 0 times 0 times 0 is 0. Which leads me to another thing off to the side here. I'm just going to put it here. Well, 0 to the 0th power, if we look at these rules, any number raised to the 0th power is 1. 0 raised to any power is 0. You can already see, and we said that the other value couldn't be 0 in those. We see we run into a problem. According to this rule, 0 to the 0th power, any number raised to the 0th power would make it 1. According to this rule, 0 raised to any power is going to be 0, would make it 0. So basically we have a discrepancy here. Both can't happen at once. 0 to the 0th power cannot be 1 and 0 at the same time. So 0 to the 0th power is undefined. So these are very important things to know. I love to ask students some really horrendous question and raise it to the 0th power so that all I have to do is determine whether what's inside is 0 or not. If I have 0 raised to the 0th power, it's undefined. If I have any number raised to the 0th power, it's going to be 1. So I love doing that, things like that to students to throw them off. But those are 3 big things that you want to make sure that you're aware of. Any number raised to the first power is itself. Any number raised to the 0th power is 1. 0 raised to any power is 0. And 0 to the 0th power is undefined. Okay? So let's just do a little bit more. I'm just going to give you a little more information about exponents. If we are dealing with exponents of whole numbers, so the base is a whole number, and we raise it to some power. If that exponent is greater than 1, so let's put this, so we have our base is a whole number. And I should really say that it's a whole number greater than 1, because we know that if it's raised to the 0th, if it's the base is 0, 0 raised to any number is going to give you 0. If it's 1, 1 raised to any number is going to give you 1. Right? So if base is a whole number, if the exponent is greater than 1, so you have a whole number and the exponent is greater than 1, then the result is going to be greater than the base. So basically, you've got a base that's a whole number and you raise it to some power greater than 1, you're going to get a larger result than that base was. If the exponent is less than 1, then your result's going to be less than the base. So a whole number base raised to a power greater than 1, it's going to make the number bigger. A whole number base raised to a power less than 1, it's going to make the number smaller. So let's take a look at that. Just our final step here with this. Three to the 5.6. 5.6 is greater than 1. So 3 to the 5.6 gives us 469.76, doing whatever it does. Exponent's greater than 1. This 3 becomes a number larger than 3. 3 to the 0.7. Base is a whole number. Exponent is less than 1. Therefore, we should get a number smaller than 3. So 3 to the 0.7 gives us 2.157, doing whatever it does. So we see that taking this base and raising it to a number less than 1 gives us a number smaller than it. We could safely say that as long as the base is greater than 1, then any exponent greater than 1 is going to increase the size. and any exponent less than 1 is going to decrease the size. It actually runs the opposite direction if the base is between 0 and 1, and that's why they said whole numbers. But if the base is between 0 and 1, then a larger exponent is going to make it smaller, and a smaller exponent would make it larger. Well, we're not going to deal with that at this point in time. So that's talking about exponents.